Hey everyone, welcome back to the channel. Today we're diving into the wild world of web application security. We're talking about cross-site scripting, or XSS, a vulnerability that can turn a website into a hacker's playground. XSS attacks can be pretty nasty, but don't worry, we're here to give you the tools to fight back. Today we'll explore the different types of XSS attacks, the techniques developers use to prevent them, and the potential consequences if these attacks are successful. So buckle up, grab your thinking caps, and let's get started. Alright, before we can prevent XSS attacks, we need to understand what we're dealing with. XSS, or cross-site scripting, is a type of security vulnerability typically found in web applications. It allows attackers to inject malicious scripts into content from otherwise trusted websites. Let's break down the three main types of XSS attacks: stored XSS, reflected XSS, and DOM-based XSS. Each of these types has its own unique method of exploiting vulnerabilities in web applications. First up, stored XSS. This type of attack is also known as persistent XSS. It occurs when malicious input is stored on the target server, such as in a database, comment field, or message forum. A hacker injects malicious code directly into a website's database. This code is then served to users whenever they request the stored information. Whenever an unsuspecting user visits that page, the malicious code is executed in their browser, potentially stealing their information or performing other malicious actions. The impact can be severe, leading to data theft, session hijacking, or even defacement of the website. Next, let's talk about reflected XSS. Reflected XSS occurs when malicious code is reflected off a web server, such as in an error message, search result, or any other response that includes some or all of the input sent to the server as part of the request. The attacker sends malicious code to the victim through a link or form submission. When the victim clicks the link or submits the form, the website reflects this code back to the user's browser, where it's executed. This type of attack is often used in phishing scams to trick users into executing malicious scripts by clicking on a seemingly legitimate link. Finally, we have DOM-based XSS. DOM-based XSS is a bit different from the other two types. It occurs when the vulnerability exists in the client-side code rather than the server-side code. By injecting malicious code into the DOM, attackers can manipulate the website's content and behavior without needing to interact with the server. This can lead to unauthorized actions being performed on behalf of the user. Each type of XSS attack exploits a different vulnerability in a website's code. Stored XSS takes advantage of poor input validation and data sanitization on the server side. Reflected XSS relies on the website reflecting user input back to the browser without properly sanitizing it. This can happen in search results, error messages, or any other part of the website that includes user input in the response. DOM-based XSS exploits vulnerabilities in how the website interacts with its own code, often through client-side scripts that dynamically update the page's content. Understanding these differences is crucial for developers to implement the right security measures. By knowing how each type of XSS attack works, developers can better protect their applications and users. This includes validating and sanitizing user input, using secure coding practices, and regularly testing for vulnerabilities. With the right precautions, we can significantly reduce the risk of XSS attacks and create a safer web environment for everyone. Now that we've delved into XSS attacks, let's talk about how to prevent them. Preventing XSS attacks is crucial for maintaining the integrity and security of your web applications. By implementing a series of best practices and security measures, you can significantly reduce the risk of these attacks. First, input validation. Validate all user input to ensure it doesn't contain harmful characters or code. This means checking for unexpected input types, lengths, and formats. By doing so, you can catch potentially malicious data before it has a chance to cause harm. Next, output encoding. Encode data displayed to the user to prevent the browser from misinterpreting malicious code. This involves converting characters like "and" into their HTML entity equivalents, ensuring that any potentially harmful code is rendered harmless. Content Security Policy, CSP. Implement a strict CSP to prevent malicious scripts from loading from external sources. A well-defined CSP can restrict the sources from which scripts, styles, and other resources can be loaded, adding an extra layer of defense against XSS attacks. Cookie security. Set the HTTP-only flag on cookies to prevent malicious scripts from accessing sensitive information. This flag ensures that cookies are only accessible through HTTP requests and not via client-side scripts, reducing the risk of sensitive data being exposed. Header security. Set specific security headers like XSS protection and X-frame options to instruct the browser to take additional security measures. These headers can help prevent XSS attacks by blocking suspicious content and ensuring that your web pages are not embedded in frames from other domains. Regular security audits. Regularly review code for potential vulnerabilities and test websites for XSS attacks. Conducting frequent security audits helps identify and address weaknesses in your web application before they can be exploited by attackers. Web Application Firewalls (WAFs). WAFs act as a shield, filtering out malicious traffic and preventing attacks before they reach the server. By monitoring and analyzing incoming traffic, WAFs can detect and block malicious requests, providing an additional layer of protection. Many of these security measures can be implemented with relatively simple code changes or by using existing security tools and frameworks. Leveraging these tools can streamline the process of securing your web applications, making it easier to maintain a robust security posture. The time and effort invested in implementing these measures are minuscule compared to the potential damage of a successful XSS attack. By proactively addressing security concerns, you can protect your users, your data, and your reputation from the devastating effects of cyber attacks. Let's look at some real-world examples of XSS attacks. Cross-site scripting, or XSS, is a type of security vulnerability typically found in web applications. It allows attackers to inject malicious scripts into content from otherwise trusted websites. These scripts can then be executed in the victim's browser, leading to various harmful outcomes. Imagine you're browsing an online forum and click on a link that redirects you to a malicious website designed to steal your login credentials. This is a common scenario where attackers exploit the trust users have in a website. The malicious site may look identical to the legitimate one, tricking you into entering your sensitive information. This is a classic example of a malicious URL. Such URLs can be crafted to look very similar to the real ones, making it difficult for users to distinguish between the two. Once you enter your credentials, the attacker can capture them and use them for unauthorized access. Now, let's say you leave a comment on that forum thread. You might think it's harmless, but if the forum is not properly secured, it can become a playground for attackers. If an attacker injected malicious code into the comment section, that code could be executed when you submit your comment. This could lead to your browser executing the malicious script, which might steal your session cookies or redirect you to a harmful site. This is a prime example of a malicious comment. Such comments can be used to spread malware or phish for sensitive information. The attacker can manipulate the comment to execute scripts that run in the context of the user's session. Finally, imagine filling out a form on a website. Forms are a common feature on many websites, used for everything from signing up for newsletters to making purchases. Attackers can inject malicious code into form fields, which can be executed when the form is submitted. This type of attack can lead to data theft, unauthorized transactions, or even complete takeover of your account. This is what we call a malicious form field. The injected code can perform various malicious actions, such as stealing the data you enter or altering the form's behavior to benefit the attacker. These examples show how XSS attacks can play out in the real world and why it's important for developers to take precautions. By implementing proper security measures, such as input validation and output encoding, developers can protect their applications and users from these sneaky attacks. Always be cautious and aware of the potential risks when interacting with online content. Let's talk about the potential consequences of a successful XSS attack. One common consequence is data theft. Malicious scripts can steal personal information like login credentials and credit card details. Another consequence is session hijacking. Attackers can use your session key to impersonate you and access your account. XSS attacks can also distribute malware. You might download a malicious program that infects your computer with a virus or spyware. Lastly, XSS attacks can lead to denial of service (DOS) attacks, overwhelming a website with traffic and making it inaccessible to legitimate users. These consequences highlight the importance of preventing XSS attacks. Well, there you have it, folks. We've journeyed through the treacherous terrain of XSS attacks explored their various forms, and learned about the crucial preventative measures that developers can take. We've also seen firsthand the potential havoc these attacks can wreak if they succeed, from data theft to malware distribution. Thanks for watching. Remember, understanding and preventing XSS is crucial for maintaining the security of your web applications. It's like wearing a seatbelt in a car. You might not always need it, but when you do, you'll be glad you had it. Don't forget to like, share, and subscribe for more informative content on web security. Stay safe out there in the digital world. And remember, knowledge is your best defense against the ever-evolving threat of cyber attacks.